Okay, question 8, very big one. So we're given this graph and it models. So figure 1 is a graph showing the journey of a rugby ball. The height of the ball above the ground, h meters, has been plotted against the horizontal distance, x meters, measured from the point that the ball was kicked. So we're going to take the origin as the point where the ball was kicked. The ball travels in a vertical plane. The ball reaches a maximum height of 12 meters and hits the ground at point 40 meters from where it was kicked. Part A wants us to find a quadratic equation linking h with x that models this situation. Okay, so looking at the graph, we know our x-intercepts are in the origin, so 0, 0, and over here at 40. So we know then it's also going to be a negative x squared quadratic because it's an unhappy quadratic. So we can say then h is of the form ax squared add bx. Now, the reason that there's no constant term is because our y-intercept is 0. Now, because we know that when x is 40, h is 0, that means h has a factor of x minus 40. So, we could say then that h is ax times x minus 40. So, now we just need to find a. So, what else do we know? We know the maximum height. So that's going to be, at this point here, we know that that is 12. Now the x-coordinate is going to be slap bang in the middle of the origin and 40. So that's going to be at x equals 20 and y is 12. So we also know then when x equals 20, h is 12. So, substituting that in, we get 12 is equal to 28 times 20 minus 40. So that's going to be minus 20. So 12 is equal to minus 400 a divide by 400 and we get minus a is 3 over 100, so a is minus 3 over 100. So finally we can say then h is minus 3 over 100 x times x minus 40. Okay, then we're told the ball passes over the horizontal bar of a set of rugby posts that is perpendicular to the path of the ball. The bar is 3 meters above the ground. Use your equation to find the greatest horizontal distance of the bar from the origin. Okay, so there's 2 points where the bar could be. What we're looking for is, on our graph, where does h equal 3? So let's say 3 is about there. We get 1 point there at the start, and then we get another point over here. Now what we want is the greatest possible distance, so we are after this guy here. So essentially what we're doing is setting h equal to 3 and solving for x. So when h is 3, we're going to get 3 is minus 3 hundredths times x minus 40. Sorry, I lost an x. Minus 3 hundredths x times x minus 40. There we go. Okay, so let's get rid of the fraction. Nobody likes it. So if we multiply by 100, we get 300 on the left. Then if we divide by 3, we get 100 on the left. So 100 is equal to, now if we expand, we go minus x times x, which is minus x squared. And then we're going to get positive 40x. Right, so we got a quadratic. We want everything on the same side with a 0 on the other. So I'm going to add the x squared and subtract 40x. So x squared minus 40x, add 100 is equal to 0. Does this factor? Doesn't look like it, so I'm going to complete the square here. You could use the formula. So if we complete the square, we get x minus 20 squared minus 20 squared on the outside, which is 400. So minus 400, add 100, gives us minus 300 is equal to 0. Add 300, x minus 20 squared is equal to 300. So if x minus 20 squared is equal to 300, square root x minus 20 is equal to plus or minus root 300. Add the 20, x is 20, add or minus root 300. Now we want the greatest distance. So that's going to be 20, add root 300. Now that should be fine as an answer. Meters, remember, that's probably important. So they haven't said to give it 20 decimal places, but if we wanted to, we would get 37.32 meters. Cool. Okay, then part C wants us to give one limitation of the model. So, just think about everything we were told about the model. We weren't told anything about air resistance or any resistant forces, so there's one. We're not told whether or not the ball is spinning. That would affect everything. We're not told whether the ball is kicked from the ground or whether the rugby player is dropping the ball and kicking it. We've assumed the path of the ball would be a perfect parabola, which probably not. We've assumed the ball travels in a vertical plane, so it has no. So what that means is, imagine from whoever kicks it, from their perspective, the ball is just travelling straight forward, so it's not going left or right at all. That's probably not the case. So anything like that, and you're cool. Cool.